Hello again. Thank you for joining us today for this webinar organized by BlueUp RTLS, BLE, Mesh, or AoA, how to choose the right technology for your project. So let me introduce myself. I'm Marianna Buccero, Head of Marketing and Communication, and today we will try to clarify the different technologies available for localization and tracking in the IoT field, analyzing their features, advantages, and selection criteria to help you identify the solution that best fits for your project. Perfect, so I think we can begin. Let's start with an overview of today's topics. We will begin with a brief introduction of BlueUp to give context about who we are and our positioning. Then we'll introduce the concept of RTLS, explaining why BlueUp has specialized in developing Bluetooth low energy-based localization solutions. We'll go into detail on the main localization technologies, analyzing BlueUp RTLS platforms, and conclude with a comparison of the different solutions, focusing on the selection criteria, application, and the most relevant use cases. The goal is to guide you through a complete journey from theoretical foundations to practical examples and decision-making criteria. Before diving into the topic, let us briefly introduce ourselves. BlueUp is based in Tuscany between Florence and Siena. It was founded in 2014 and is listed among the innovative small and medium enterprises by the Italian Ministry of Enterprises and Made in Italy. We design and manufacture IoT devices, systems, and solutions for identification, localization, tracking, and monitoring. We have an in-house research and development department covering hardware, firmware, and software development, which allows us to offer a complete, highly customizable solutions. To conclude, here are a few numbers that reflect our experience. Over 500,000 devices sold and more than 1,500 customers across over 50 countries. So let's now move to the core of the webinar by introducing what an RTLS is. RTLS stands for Real-Time Locating System, and it is a system that enables real-time localization and tracking of objects or people within a defined area. It is also called LPS, Local Positioning System, and as opposed to GPS systems, which operate on a global geographic scale. The basic principle is simple. Tags are attached to objects or people to be tracked. These tags communicate with a network of fixed anchors installed in the environment. A software platform collects all this data and calculates the estimated position, updating it in real time. In general, RTLS can be used in indoor environments such as factories, offices, hospitals, and warehouses, as well as in outdoor environments like construction sites or parking areas. The main applications span across several sectors, including manufacturing, intralogistics, healthcare, smart building. And within this context, solutions can be used, for example, for monitoring the progress of activities and processes, locating assets, goods, or devices, tracking vehicles and mobile resources, access control and attendance management, monitoring spaces occupancy, ensuring the safety of workers and patients. And so, as you can see, the applications are highly versatile and span very different industries. At this point, we can move into the more technical aspects. To do so, I hand over the engineer Cucini, co-founder and CEO of BlueUp, who will guide us through the technologies and RTLS solutions, going deeper into architectures and design criteria.
Hey, thank you, Arianna, and thank you everybody for participating to this webinar, where we will try to give you an overview of theoretical aspects, but also of the portfolio of BlueUp of RTLS solutions. So let's start from the basic, so from the generic architecture of an RTLS system. As you can see here in this scheme, the RTLS core includes three main layers. A first layer, which is composed by hardware, and these are the mobile devices that are attached to assets or were worn by people to be tracked. And so we deal with wearables, tags, or labels. These are the moving devices that move around the area where the RTLS system is installed. Then we have a second layer of hardware devices that are the fixed antennas that provide the infrastructure for detecting signal and computing position. And depending on different technologies, these devices can be called gateways, locators, anchors. And finally, we have a third layer, which includes the software part of an RTLS system that typically includes all the management tools for configuring and managing the system, a user interface for accessing various functions, and the core from a computational point, which is the positioning engine. And typically, all RTLS platforms provide API to integrate data that comes from the location platform with application software that can be a standard software, can be a custom software, or can be any kind of software that is used in a manufacturing or logistic or building environment. In this, so as it was anticipated, BlueUp is focused on Bluetooth Low Energy. So we will deal with Bluetooth Low Energy as a core technology for our solutions. Just a brief history about BLE and what are the features of BLE for RTLS. So Bluetooth Low Energy was not originally designed for positioning, but it started to gaining traction in localization and tracking system starting from 2014, when Apple designed the high beacon technology for BLE beacons to be used for proximity location with smartphones. And thus, this potentiality of Bluetooth emerged for application in localization systems. So the strength of BLE for RTLS are several, including scalability, where we refer to the capability to scale infrastructure, both in terms of size and function. The low cost, especially related to the low cost of tags compared to other type of active technologies like ultra-wideband. Flexibility, which is related to the possibility to cover many functions within a single system, covering sensing, covering tracking different type of assets and people, and so on. The long battery life of the tags, which is an intrinsic feature of Bluetooth Low Energy, which was designed to be low energy, as the name reminds us. The wide market adoption of BLE that now can be found in any type of embedded devices or smartphone or tablet. And finally, BLE is an IoT-ready technology. So it provides a full stack of services that can be used for designing and systems and implementing systems. Before going into details about our technologies, it is convenient to provide clarification about the terminologies that we have used for this webinar. We have referred to BLE, to mesh and AoA, but let's see what actually refers to with these terms. Within an RTLS system, essentially we have two types of functions. One is the communication, so how tags send data to locators, and the other is the localization, so how this information is used for localized. If we refer to communication, two options are possible within the BLE framework. One is the broadcast or advertising, where the tag broadcasts a signal which is detected by locators or gateways. Another is mesh, so devices connect each other within a mesh network. If we focus on localization, BLE offers two options essentially. One is the standard and basic RSSI ranging, which is inherited from the beacon technology, where we can apply trilateration for localization. And the other one is the direction finding standard, where locators are able to estimate the angle of arrival. And so using triangulation, it is possible to locate tags. So within this framework, we have used the term BLE to refer to standard BLE platform where, like beacons, where RSSI ranging is used for location. And we have used the term AoA, which is the acronym of angle of arrival, for the BLE application with direction finding. And mesh refers to the platform where we use trilateration within a mesh infrastructure. As you can see, a fourth option is still missing at present, where a mesh infrastructure can be combined with a direction finding solution. And this is something that is yet not possible with the technologies that we have available today. Just a quick note about channel sounding, which is a new option that has been included in the last release of Bluetooth, which is the standard Bluetooth 6. Channel sounding is a type of application which allows to measure with high accuracy distance between two devices. This can play a role for RTLS, but at present is more focused for point-to-point ranging, not for point-to-multi-point ranging, which is required for RTLS. If we focus now on our portfolio, for each of these three options, we have a platform that provides a technology framework for RTLS application. For BLE, our platform is called bleenc, which is bleenc has been launched just a few months ago. It is based on standard BLE advertising, so the tags broadcast a signal using BLE advertising, and location is based on RSSI ranging. Our mesh platform is called MeshCube, and actually it uses a mesh which is not exactly BLE. It's a proprietary mesh which is based on WirePass technology, which use the same 2.4 gigahertz bands, but is not exactly BLE standard. But location is still based on RSSI range. And finally, our AoA solution is called AccuRTLS. Uses BLE advertising as a way to broadcast signal, but location is based on direction finding, and namely on angle of arrival. So let's go now in detail on each of these three solutions, showing their features and their typical architecture for a reference use case. Let's start from for bleenc. Here you can see a list of features of bleenc that includes the capability to support a two-way communication. So tags can transmit signal, but can also receive signal from antennas. The location infrastructure is an hybrid location, which use partially wired and partially wireless devices. And bleenc support a full security stack with encryption of data and authentication of devices. And since it adopts a BLE standard, it is fully compatible also with third-party BLE devices like sensor or labels. We will use this view of a floor of a building as a reference frame to highlight the infrastructure and the difference between the different solutions that we have. In case of bleenc, the location infrastructure is composed by two types of devices. First, we have the wired part of the infrastructure, which is composed by gateways. Gateways are essentially BLE scanners or BLE receivers that allows to provide a real-time tracking and location of tags. In this case, gateways are placed along the corridor of this building. But this infrastructure can be augmented by battery-powered wireless devices like beacons that provide snapshot location within certain specific areas, like rooms in this case. Snapshot location means that location is not continuous, but is provided with a certain time. It can be periodic. It can be based on a certain event, like a button press or a shock or a free fall event. The information that comes from gateways is managed by the bleenc software, and using the API can be integrated with the application software. So this is the standard architecture of a bleenc infrastructure and installation. Here you can see a list of the main features. I would like to focus on those features that differentiate bleenc from other BLE platform that you can find on the market. First of all is the bidirectional communication. So the bleenc tags not only transmit data, but can also receive downlink data from anchors, from gateways in real time. And so we can send commands, we can send configuration to tags to activate them. The other important feature is related to security and cybersecurity. So the bleenc tags transmit information which is fully encrypted, and devices are authenticated. This is very important, especially in view of the new regulation for European Cybersecurity Act, and in general for managing security and privacy within this system. And one of the last features that we have added in bleenc is the capability to support e-paper display. This means that within one single infrastructure, we can manage both localization and e-paper displays, avoiding duplicate hardware and duplicate software. Again, I want to focus on the difference between bleenc and a standard BLE RTLS platform that are available on the market. And this is mainly related to the different infrastructure which is adopted by bleenc. So as I mentioned before, bleenc uses an hybrid infrastructure where you have both wired devices, the gateways, and wireless devices, beacons. So if we refer to an area like this, can be an hospital or can be offices, you can see that we can install gateways just in the corridors, for instance, and provide localization in room with beacons. This means that with the same area to cover, we can highly reduce the number of gateways that are needed for localization compared to standard BLE infrastructure. This means that we can reduce wiring, we can reduce cost and timing for installation. In general, we can reach up to 50% saving on these different factors. So let's move now to the second solution, MeshCube, which is based on a mesh infrastructure. In this case, MeshCube does not allow a continuous tracking like BLE or like AoA, but provides a periodic tracking. This means that position is updated with a certain interval, typically can be in the order of minutes, but is based on a fully wireless infrastructure. So this means that no cables are needed for creating the infrastructure for location, and still support full encryption and authentication of data. If we refer to the architecture, still referring to the same scenario, we can see that now all the devices are fully battery operated and connect each other within a mesh network. This means that no wire is required to implement this infrastructure. Tags can be worn by people or attached to assets. And all the information coming from the network is connected to the software using a few gateways that are installed within the area. But the number of gateways typically is very limited compared to the number of anchors. So if we now focus the attention on the features of MeshCube, for sure what emerge is this wireless infrastructure. So no wiring is required by using the low energy mesh protocol from WirePass. The low cost of the full solution, since a lot of engineering cost and installation cost are avoided using this type of solution. And for sure, this type of architecture is suitable for retrofitting, and in general is suitable for all type of projects where wiring is not possible or can be very expensive. And this the WirePass mesh network also provides high scalability of the infrastructure, since expanding the system just required to add few anchors without planning any type of IT infrastructure or wiring. Finally, the third solution is based on angle of arrival. It's called AccuRTLS and still use BLE advertising like bleenc, but with different type of packet formats that are compatible with direction finding algorithms. In this case, we have the capability for continuous tracking, still have two-way communication, but the infrastructure in this case is fully wired, since the antennas needs to be always scanning for tags. And in this case, antennas are more complex, since have to compute the angle of arrival of the signal of each tag. Limitation of AccuRTLS are mainly related to the security, since encryption is not yet supported, and to the limited support of third-party BLE devices. In this case, the infrastructure reminds us typical infrastructure of a BLE location system. The difference is that the antennas, that is in this case typically are called locators, as they are more complex, typically are installed on the ceiling, and they are able to estimate the angle of arrival of the signal, and from this information, using triangulation algorithm, the position of the tag is estimated. This kind of technique provides higher accuracy, but in some cases clearly require more locators. And similarly to the other solutions, all the information coming from the network of sensor is managed by our software, and data from our software can be integrated into third-party software using our API. So which are the main features of AccuRTLS? For sure, the performances in terms of accuracy. With angle of arrival, we can reach high accuracy, in general, sub-meter accuracy, also even in complex environment, with a real-time localization. So this means that we can track in real time with high accuracy. And antennas are able to provide high capacity of tracking. So this means that we can manage installation and environments with a high tag density. And typically, and usually, the antennas for angle of arrival are always installed on the ceiling. This means that if we have project with high ceiling and open area, angle of arrival can be the ideal solution. So now, after this view of each individual platform with its own features, we can compare them, and in terms of different parameters. So first, let's start from performance, where performance is measured with two indicators. One is the accuracy, the localization accuracy, which refers to the average error that the system provides in estimating the position. And the other one is the interval, so how frequently position is updated by the system. As you can see, from AoA to BLE and Mesh, we move from bottom to top and from left to right. AccuRTLS and AoA in general provides the higher level of accuracy. So we are in the range of meter accuracy with real-time refresh. This means that the latency is very reduced, in the order of 1 second. With bleenc, we still keep low latency of data, but the accuracy is lower because RSSI ranging is intrinsically less accurate than direction finding. While with MeshCube, we have a similar performance in terms of accuracy, but the capability of the system are restricted in terms of continuous sampling. So it is suitable for localization projects where we can refresh position data, for instance, every 1 minute, 10 minutes, or more. If we move the comparison to the cost, clearly we can see that we have the opposite scenario, where AoA is the more expensive, while the mesh solution is the less expensive. Here we propose a comparison based on the 4 main factors that has an impact on the cost of RTLS project, which is related to the cost of the tag, which is here normalized per piece, per single piece, per single device. Then there is the cost of locators or anchors, which here is normalized per square meter. All the costs are in euro. Then there is the cost of the software and all related licenses. And finally, all the costs that are related to auxiliary hardware, like servers, cabling, and so on, or IT infrastructure, and all the services from survey to design and installation cost. Clearly, these costs are normalized, but there needs to be intended as a relative cost among the 3 different solutions in order to compare the differences between Mesh, between BLE and AoA. As you can see, AccuRTLS has higher cost, mainly related to the cost of the anchors and to the cost of the software and services, while with Mesh, we can greatly reduce the cost of auxiliary hardware and services, since we have here no cabling and the design of the system is quite simple. While the BLE is somehow in the middle between these 2 opposite systems. And if we enlarge the view also to other aspects and other features, we enlarge the comparison, we can see that, as we mentioned before, bleenc provides an infrastructure which is hybrid, so partially wired and partially wireless, while MeshCube is practically fully wireless, and AccuRTLS require a complete wiring of each locators. And I would like here to focus on the last features, like encryption of data. As you can see, both BLE and Mesh can support this feature, while at present, this feature is not supported by AccuRTLS. bleenc is fully compatible with any third-party BLE devices, like sensor or labels, so it can be used also to integrate, for instance, temperature sensors or other type of sensor or labels based on BLE, while the support of BLE is possible, but it's limited on Mesh and AoA. And finally, the capability to guarantee bidirectional communication. This is possible with BLE and AccuRTLS, although the bleenc protocol is much more efficient in terms of power consumption compared to the AoA protocol. The bidirectional communication is possible also with MeshCube, but also in this case with some limitation. And in general, if we focus on the battery life of tags, both bleenc and AccuRTLS provides the longer battery life compared to MeshCube. And taking into consideration all these aspects, we can try to provide some basic concept for choosing the right solution for RTLS projects. So when using BLE, when using Mesh, or when using AoA. So there are some criteria that can be applied in general, although each project should be analyzed on a specific case. But in general, what we can say is that bleenc, in general BLE, is the right solution when real-time visibility is required, where especially if we have buildings with rooms, or in general buildings with separate areas, and we want to guarantee a full BLE interoperability. Some use cases can be related to hospital tracking, or access control, or workstation monitoring. MeshCube is the ideal solution when periodic visibility is sufficient, so no need for continuous tracking. When the wiring is not possible or expensive, for instance, in building site or existing warehouse, and in general for all retrofitting or temporary installation. And some typical use cases for MeshCube are related to container and card search, for staged production flow, or for tools tracking in building sites. Finally, AoA and AccuRTLS are the right solution when real-time visibility is required, when high accuracy is required, and in general it's a very cost-effective solution when the RTLS project is implemented in buildings, open buildings with high ceiling, since the number of locators is highly limited in this case. And typically use cases are related to forklift tracking, continuous production flow, and tracking in high-density storage areas. But as you can see here, maybe we have projects where these different requirements can be present. So one possible approach is not to implement a single solution, but to implement a solution where two or more technologies are used. And in this case, we can create what are called hybrid RTLS architectures, where hybrid means that in the same project, we can adopt two or more technologies. We have here a couple of examples. In the first one, we have an hybrid mesh plus BLE infrastructure where mesh tags are configured to broadcast a BLE packet. So this means that mesh tags can be located inside a mesh infrastructure, but can also be received by BLE scanners. So how we can use this? For instance, we can use this for periodic location using mesh within a large area where we have a very lightweight wireless infrastructure composed of battery-powered anchors. But we can have at the same time real-time tracking of exits and entries at the gates of this area by using BLE antennas. So in this case, mesh is used for wide location in all the area, while BLE is adopted for tracking the exit and entries at all the gates. Another type of hybridization is between BLE and AoA, where AoA can be used, like in this case, for high accuracy location in a limited area. So we can limit here the number and the cost of the AoA infrastructure and locators, while for a wide area, we can adopt a zone accuracy location with standard BLE. In this case, we can base our solution by using BLE tags that can be configured to broadcast angle of arrival packets. So for instance, our bleenc tags can be configured to transmit simultaneously their standard packet and angle of arrival packet. So let's see a few examples of projects where we can showcase the flexibility of these RTLS solutions and in general different types of applications. So let's start from a typical healthcare project. This is a leading Italian hospital that needed to track the location of beds and portable medical devices within rooms and wards, but they also want to monitor in real time the entry and exits of these assets from the department. So, and the third requirement was also to implement and integrate in the future sensor, especially BLE sensor for temperature and humidity monitoring and other type of sensing. So for these reasons, we decided to adopt bleenc platform based on BLE, where tags are applied to all the medical assets, and we install gateways along the corridors and beacons for room location in all the rooms of the ward. And the project is being scaled to a few floors inside the hospital, and we have already some results, especially related to the improvement in the utilization rates and reduced search times for the assets. A second project is in the textile industry. Specifically, the customer produces textile products for different markets, ranging from industry to automotive, and they needed to track their internal production and quality control processes to verify timing of all this, timing and duration of all this process. The products and the raw material are moved within the plant using special trolleys to the various stations up to the final quality control. So in this case, since the environment was quite complex and there was no possibility to install wired devices, we adopted the mesh technology with MeshCube platform by applying tags to each trolley. All the tags have a QR code that allows to associate the trolley to that tag and allows to associate the production order to that trolley when this is managed by the workers inside the plant. And the mesh network has been deployed in all the areas that are involved by the project, so the production, the storage, and the quality assessment area. And with this system, we provide a real-time visibility to all the production processes, and the customer eliminated all the bottlenecks and reduced the delivery times for their customers, and so also improve the quality of services. Finally, for final project in the steel industry sector, in this case, this is an leading Italian steel mill that aimed to implement an automatic tracking system for all raw material flows. And the primary objective was to increase the efficiency of their operations and to reduce the error rate, but they also want to implement the tracking function to certify their processes in order to improve the quality of services for their customers. And in this case, the technology that has been adopted is AoA with AccuRTLS platform, especially because in this case, we deal with open areas. So there was a lot of metal inside. The area is open, so no walls, no obstacles. And there was the possibility to install AoA antennas on the warehouse ceiling, which was 12 meters high. And then the localization software has been integrated also with some special functions that allow to track, for instance, the vehicle shape by placing more than one tag on each vehicle. And in this case, we reach the 100% of accuracy in estimating all the operation inside the warehouse, and the system has been fully integrated into the ERP software of the company. So to conclude this webinar, I hope that we have provided sufficient quantity and quality of information. But in case you are interested to start testing our solution and in general this type of technologies, we can provide starter kits for each of our platform for bleenc, MeshCube, and AccuRTLS. The bleenc and MeshCube starter kits are already available, while for AccuRTLS we are going to finalize the starter kit and it will be available, I think, before the date that is listed here. Maybe in the next few months it will be available also the starter kit for AccuRTLS, and all the starter kits are intended for a fast deployment and fast testing of the system functionalities. Okay, and with this I have completed my presentation. Thank you for the attention.